Hello, sixth graders. We are looking at prime versus composite numbers today. So your learning targets, there's two of them you need to have written down in your notes along with the title. But the learning targets are, I can determine if a number is prime or composite, and I can identify properties of prime and composite numbers. Okay, we have some vocab here that needs to be written down. We're looking at how do you know if a number is prime or composite? So we need to know what those words mean. So a prime number is a whole number and remember you should be writing these down, greater than 1, and it has two factors, one and itself. Sorry, my handwriting is not the best here. Okay, so that's a prime number. Composite, again, whole number greater than 1. Number greater than 1. And then now this time though, it has more than two factors. Okay, the next word we are looking at is divisible. So this means that it can be divided by. Okay. So for example, 25 is divisible by 5. So it means that we can divide 25 by 5. Or 30 is divisible by 2 because it can be divided by 2. And our last word here, factors. Those are the numbers that are multiplied together to make another number. Okay. So for example, for this one on, let me think of an example here, 18. Factors of 18, so those are the numbers that would multiply to make 18. Well, 1 and 18, I can multiply 2 and 9 to make 18, or I could multiply 3 and 6 to make 18. So all of those numbers that multiply together to make another number. Okay, so here we're looking at how do we tell if a number is prime and how do we tell if a number is composite. So what we always do for any numbers, list out the factors. Okay, again, those are the numbers that multiply together. So list out all of the numbers that multiply together to make up another number. If there's only one in itself, then it is prime. If it has more than two factors, then it's a composite number. Okay, so we'll get to this in some examples, but list out all the factors. 2 or more, it's prime. Sorry, 2 or more than 2, it's composite. There we go, 1 in itself, so 2 factors, and it's prime. What about 1 and 0? Well, let's think about this. With the number 1, what are the numbers that multiply together to make up 1? Well, 1 times 1. So its only factor is 1. But in order to be prime, it needs to have 2 factors. But 1 only has 1, so this is actually neither prime or composite. Now 0, what numbers multiply to make 0? Well, 0 and 1, 0 and 2, 0 times 3, 0 times 4, and it just keeps going on forever and ever and ever and ever. So in that case, this one is also neither, because it has an infinite amount of factors. So here's where we're going to practice. So we are going to list out the factors for these numbers, and then from there we can then decide if they are prime or composite. So for 13, the numbers that can multiply to make 13 are 1 and 13. There's nothing else that can multiply to make 13, so those are the only factors, so therefore it is a prime number. Okay, the next one, 32. So if we list them out, I know 1 and 32. 2 times 16 is 32. This is where a multiplication chart would be really helpful if you're stuck on this kind of stuff. I don't think 3. I know 4 and 8. And I think that would be it. So because it has more than 2 factors, this one would be composite. Change my color here. The next one, 19, the numbers that multiply to make 19. Well, obviously 1 and 19. 1 in itself will always be factors, but we're just seeing if there's more. I don't think there is any more, so this would be prime. Okay. Next one, 44, 1 and 44. 2 and 22. I know 4 times 11. And I think that's it. So because there's more than 2 factors, we've got 1, 2, 3, 4, 5, 6. That's a composite number. More than 2, composite, 1 in itself, prime. Next one for 30. Well, 1 and 30. What else? We've got 2 and 15, 3 and 10. 4 doesn't go into it. 5 times 6. I think that would be all of them. So, because there's multiple, more than 2, this is a composite number. For 9, 1 times 9. 3 times 3, I'm only going to list 3 once though, because we don't need to duplicate that. So it's got more than 2 factors, so that's a composite number. And the last one, 0, this one we talked about on the last page. So it would be 0 and 1, 0 and 2, 0, 3, 0, 4. Keeps going forever and ever, so that is neither. It is neither prime nor composite because it has an infinite amount of factors. Here's a little visual to help you. This would be a great thing to have written down in your notebook. Okay, I'll highlight it here just to help you remember. Prime versus composite numbers. So prime have only 2 factors, 1 in itself. So there's a few examples there. 2 is prime, 3 is prime, 5, 7, and 11. Fun fact about 2, I think that's the only even number that is prime, because every other even number can be divided by 2, so it makes it composite. Composite have more than 2 factors, and there's just a few examples. That's not all of the composite numbers, and that's not all the prime. And then remember, 0 and 1 are neither. Okay, so I'm not going to go through these ones, so this is a little check-in for me. So what I'm going to do is when you post these notes or when you show them to me, I'm going to be looking to see that you have these problems completed as well. So you're going to copy these numbers in your notebook, 13, 65, 18, 49, 73, and 51. Then for each of them, you're going to list all of the factors, and then from there, you can determine if it's a prime or composite number. When you include your pictures of your notes, you're going to make sure that you include this part as well. I will be looking for this as well as all of the other examples and vocab throughout this video. So try these ones. I'm not going to go through them. You're going to try these ones on your own as a check-in. So that's all that I have for this video. So go back and check your understanding. Is this something that you could explain to a friend? Rewatch parts of the video if you are still stuck. Try more practice problems, and then don't forget to post your notes to the Slides on Class Kick.